Okay, we're going to finish up this exam review, do questions 11 through 15. In this problem, we're asked to simplify. In other words, we need to remove the radical from the denominator of this fraction. And in doing so, what we have to do is we have to multiply by a form of 1. Sometimes the radical itself is the form of 1, but in this case, because that plus is there, we've got to multiply it by the conjugate. The conjugate of 4 plus this 7 times the square root of 7 is 4 minus 7 times the square root of 7. So that is going to be our form of 1. We know that when we multiply anything by 1, we get that number itself. This is going to be an equivalent answer. It's not going to look the same, but it will be equivalent. In the numerator, we can, I'm just going to leave it for the moment as 6 times 4 minus 7 times the square root of 7, simply because sometimes when you simplify things in the end, it makes it easier if you don't distribute that out first. Next, I'm going to multiply the denominators together. And I want to make note that these are conjugates, and we know that when you take the product of conjugates, a plus b, a minus b, you get a squared minus b squared. So all we have to do is square the first terms and square the second terms, and we will have a simplification. So when we square 4, we get 16. Then when we square 7 times the square root of 7 times 7 times the square root of 7, we get 49 times the square root of 49. And we're going to switch that square root of 49 out for 7. Okay, and so this gives us 6 times 4 minus 7 times the square root of 7 over 16 minus 343. That's kind of a huge number there, but let's continue this process. Again, I'm just going to rewrite the numerator. And 16 minus 343 is negative 327. Okay, once again, these are kind of large numbers, but let's see if we can simplify this any. I can tell by looking at this that this is divisible by 3. So if I were to write this, I would get 109. So you'll see in a second why I'm doing this. The 6 in this numerator, and again, the reason why I did not distribute this 6 was for this reason. Okay, now what I can do is I can actually cancel this 3 with this 6, making this a 2. And this negative can remain in the downstairs of the fraction or in the denominator, or it can be brought up to the top. It really does not matter. What I'm going to do is, again, now I'm ready to distribute that 2. I'm going to get 8 minus 14 times the square root of 7 over negative 109. This is one form of the answer. If I had chosen to have brought that negative to the numerator, an equivalent answer would have been negative 8 plus 14 times the square root of 7 over positive 109. And again, all I did was transfer that negative to the numerator and distributed it. So these are both equivalent answers. Let's move on to number 12. Okay, we've not really done one like number 12, but I wanted to show it to you anyway because it's a very easy question. You have a real number line and imaginary axis. And to graph this, you just simply plot you start with a real number, which is 4. 1, 2, 3, 4. And then you go up 1, 2, 3, 4, 5. This is 5i. So that's where you're going to plot that point. It's just that simple. And on this one, we're going to graph this parabola. First thing we need to do is we need to find the vertex. And so as I look at this, I see that a is equal to negative 1, which makes it a concave down parabola, and b is equal to negative 4. So when I plug these values into this negative b over 2a, I get a positive 4 over a negative 2, which is equal to a negative 2. And now I need to run that negative 2 through the equation. So that's a negative 2 quantity squared minus 4 times negative 2 minus 2. And as we evaluate this, we're going to make sure we do these exponents first. A -2 quantity squared is a +4, but it's greeted with a negative. So that's actually going to be a -4. I'm going to bring this down here. A -4. And then this -4 times -2 is a +8 minus 2. This gives us 4 minus 2, which is equal to 2. So that's the hard part's done with. Find -2, +2, and plot the vertex. Next, the pattern that this is going to be is down, because that negative, that leading coefficient, determines the pattern and the concavity. So the pattern's going to be over 1, down 1, over 1, down 3. And you want to do the reflection points over here on the other side. And then you can sketch your graph. And you know this is the part that I'm not very good at. So connect your dots, and that's a really sad graph in many respects. Let's move on to number 14. This time we're solving by taking square roots, which simply means we're going to isolate the k squared. Add 5 to both sides. It knocks the 5 off of the left. We're left with k squared is equal to 13. And we're solving for the two values of k. So we can take the square root of both sides, and we get plus and minus the square root of 13. And our last question is similar, but we're going to have some big differences here. Again, we're going to divide by 7 because we're isolating the p. And we get p squared is equal to 84 divided by 7 is going to give us a -12. And then when we take the square root of both sides, oops, we got that negative underneath the square root symbol. We know we're going to trade that out for an I. So this will be plus and minus I times the square root of 12. And once again, that 12 has a hidden square root in it, which is the square root of 4 times the square root of 3. And we're going to trade that square root of 4 out for a 2. And so the square root of 12 is actually equal to, or equivalent to, 2 times the square root of 3. We've already got that I there. So our answer is going to be plus and minus 2, let's stick that I back in, times the square root of 3. And those are your two answers. And that concludes the video and the exam review.